Now let us see. Now in case of string, we had discussed that when we need to append too many times to a string, like as I'm giving an example. So as I have just concatenation, I have used just once, but in case you have a number of times you need to concatenate a string with some other string, then we had put on that every time you concatenate something to a string, you waste an object in memory. So it's better whenever you need to operate on a string very frequently, then we have better options available like StringBuffer and StringBuilder. So we have two classes available, StringBuffer and StringBuilder. Now the classes are exactly same with a very slight difference. StringBuffer is thread safe. So in case multiple users are accessing a buffer, so it is safer to access through a string buffer because it has every method synchronized, which means that only one user can operate a method, and when one user is running a method of string buffer, other users will be in a wait state. Whereas, so this obviously means that you are putting everybody in a queue. So this takes more time than in a multi-threaded environment. So just to avoid the time that it takes in a string buffer, we have a string builder class which is not thread safe but much faster than a string buffer. So in case we need thread safety, we can use string buffer, and in case thread safety is not an issue for us, then we can use string builder. So the main difference between the two classes is the thread safety. String buffer has been designed to be thread safe, whereas string builder has been designed not for thread safety but rather to be more quick in operation. So I'll just build using string buffer, and then accordingly you can use string builder. It has exactly the same methods and exactly the same way to operate like a string buffer. So I can have a starting string, say st is equal to this. Now I build a string buffer on this, new string buffer. I build on this st, and then you can append anything to this buffer. So you can append anything, any kind of data you can append to the string buffer, and when you are finished off with appending, then you want to take out the contents of the string buffer. Then we have a simple method which is sb dot toString. So this will return you the string form of the contents of the string buffer. So whatever content you had in the string buffer, this will return as a string. So we can print down this new string. So this is a much efficient way of appending data to a string rather than using the concatenation operator. We'll just see in a minute how memory is affected and how much time is affected when using the same append and doing the append using a concatenation operator. So we have got this is Java. So there are some methods we can see in a string buffer. Now I have a string. We had just in a previous tutorial seen how to check for a palindrome, and we can make the same program using a string buffer. I can say dot dot. So this we took as a example in that. So I build a string buffer on this string. I reverse this and then get the string out from it, and now I can compare if st dot equals new st, we can say it is a palindrome. Else we can say it is not a palindrome. So I'll just check this up. So it is a palindrome. So this is a much easier way to do the same thing that we did with the string. We had character arrays and we found out this is a palindrome or not using arrays. So this we had a string buffer on the string. We use the reverse method of the string buffer, and then we have compared the new string with the original string. Now we have some methods like capacity, and another method is the length. Now capacity will give what is the capacity of the string buffer to store data, and length it will give us the number of characters that it is currently storing. So we had 23 is the capacity of the string buffer, and currently it is storing 1 2 3 4 5 6 7, and this is what it is returning us, that it is storing 7 characters. So now let me design a small program to see how much time it takes between the plus operator and the string buffer operator. So I'll just have keep this as a start point. Now I'll have a initial time in current time milliseconds. So now we have the start time. I put this start. Now system dot current time millis, it gives you the time in milliseconds from January 1 1970 till the current date. So we'll take this as a start point, and we also need to have the current memory that we have free. For this we'll use the runtime class. I'll say free memory. So this is the free memory at the beginning of the program. Now I'll design a loop. I'll say for I, suppose I'll append 10,000 times to the string st plus equal to is. So I'm appending this is to the st, the original string, 10,000 times, and after going through the loop I'll again see what is the time and what is the memory currently we are having free. Now I can print down time taken is end minus start. This is the millisecond taken to execute the loop. And let us see what is the memory. Minus start. So this is the memory taken by the loop in concatenating the string 10,000 times. Now we will reinitialize the values. Start goes equal to end, and end name goes equal to start. So now I will again run this loop, but this time instead of the plus operator I will use append and append the same string, and now I will again calculate these values and calculate the time and memory taken. So this gives us a rough idea of how exactly this system works for string buffer and for the string concatenation operator. So just run this program and see what values we get. Just see, it has taken 371 milliseconds in this case, whereas it has hardly taken 1 millisecond to run for a string buffer. And this is the memory taken in case of let us see what difference it is, why this is coming. Let us see, and is equal to this. One is that the free memory at the start, it is more than the free memory at the end. So this is one mistake we have made, that is why the result is coming out to be negative. Here also I make the change. Now start minus end. Okay, start is equal to end. I made a very basic mistake. We need to pass the value of end to start, and we have passed the wrong value. So I've set the things right. We had end with this, then we have calculated the difference, then start has been given the value of end, start m given the value of end m, and again we have seen the time, we have seen the memory, and we have calculated the difference. So let us run the program again. So now we can see it has taken a time of 332 milliseconds, a memory of around 26 lakh bytes, whereas this has taken only 1 lakh bytes and 2 milliseconds. So this is the difference between the process that is done through the plus operator, and if the same process is done through the append method of string buffer, so it leads to substantial saving in time and memory. So this is how we can see that this is the right way to appending any content to a string rather than using the plus operator.